Welcome, space enthusiasts, to another exciting episode of Elon Empire. Today, we're diving into the remarkable transformation underway at SpaceX's Starbase in Boca Chica, Texas. This site, known for its groundbreaking advancements in space exploration, is experiencing its most significant overhaul yet. As new prototypes and systems emerge, older structures are being systematically phased out to make way for the future. In this episode, we're focusing on one of the key components of Starship's development, Test Stand B. This test stand has been integral in the evolution of the Starship program, providing a platform for countless static fire tests and other critical evaluations. Join us as we explore this legacy of the Test Stand B and its crucial role in reshaping the future of space travel. Test Stand B has been a cornerstone of SpaceX's testing infrastructure at Starbase. Erected in late 2020, it has supported numerous milestones in the development of the Starship. From the fiery static fire test to the meticulous spin prime and cryogenic tests, Test Stand B has been instrumental in validating the various components and systems of the Starship prototypes, including notable iterations like the SN9 and SN11. Its contributions have been pivotal in refining the technology and ensuring the reliability of the spacecraft. However, the era of Test Stand B has come to an end. Just a few days ago, the demolition of this venerable test stand began, marking the conclusion of its service to SpaceX and the Starship project. The dismantling process was set in motion shortly after the final test involving the S-30 prototype. On May 12th, workers initiated the removal of the Ship Quick Disconnect, or SQD, umbilical cord, a critical component in the refueling process for each test. Following this, the SQD support frame was taken down, further signaling the end of operations at Pad B. The demolition proceeded methodically, with excavators and cranes mobilized to deconstruct the remaining structures. By the afternoon of the 12th, significant progress had been made and the site began to clear. The legs and the table of Pad B are slated for removal next, signifying the complete dismantling of this iconic stand. This meticulous process underscores SpaceX's commitment to advancing its infrastructure in line with its ambitious goals. The removal of Test Stand B not only makes space for new development, but also symbolizes the relentless drive for innovation that defines SpaceX's mission at Starbase. Test Stand B has been essential of an asset in the development of SpaceX's Starship program, marking numerous historical milestones since its inception. Constructed in the late 2020s, Pad B quickly became a crucial testing ground for validating the design and performance of Starship prototypes. One of the standout moments in its history was a series of tests conducted by the SN9 prototype. In January 2021, SN9 underwent multiple static fire tests on Pad B, which are pivotal in refining engine performance and ensuring the reliability of the Raptor engine. Another significant milestone was the testing of SN11. Despite the eventual failure of the SN11 test flight, the data gathered from the static fire and pre-launch tests at Pad B provided valuable insights that have shaped subsequent Starship iterations. These tests highlighted critical areas for improvement, such as engine reliability and structural integrity, which have been addressed in newer prototypes. Beyond individual prototypes, Pad B has also been instrumental in advancing the overall testing procedures for SpaceX. It facilitates numerous cryogenic tests where tanks filled with super cold liquid propellant to simulate the conditions of actual launches. These tests ensure that the Starship systems could withstand extreme temperatures and pressures. Additionally, the spin prime tests conducted at Pad B were essential for verifying the functionality of the Raptor's engine's turbopumps, which are crucial for generating high-speed thrust needed for liftoff. Test Stand B's role were not limited to the individual test events, but extended to ongoing processes of iterative development. Each successful test built upon the lessons learned from its predecessors, creating a feedback loop that's accelerated the Starship program's progress. The continuous use of Pad B for these critical evaluations underscores its importance in SpaceX's ambitious quest to develop a fully reusable spacecraft capable of carrying humans to Mars and beyond. Since 2023, SpaceX has been vigorously advancing its infrastructure at Starbase, reflecting its commitment to continuous innovation and expansion. The transformative period has been significant changes, including the dismantling of older systems and the installation of new, more advanced facilities. Among the notable changes at the production site are the dismantling of the mid-bay, low-bay, and the production tent, which were essential in the early stages of the Starship program. These structures have been replaced by the Mega Bay 2 and the Star Factory, which provide enhanced capabilities for the assembly and integration of the Starship and its components. One of the most significant milestones in this ongoing transformation was the demolition of Pad A's test stand in December 2023. Pad A has been a critical component in the initial testing phase of the Starship, supporting numerous static fire and cryogenic tests. The removal of Pad A's test stand marked a decisive shift towards newer and more efficient testing facilities, reflecting SpaceX's commitment to innovation and evolving its infrastructure to meet future demands. This demolition also indicated broader strategies to reallocate resources in space to accommodate next generation systems that are essential for the ambitious goals of the Starship program. In parallel with these deconstruction efforts, SpaceX is making significant strides in constructing a new launch tower at base. This launch tower is designed to support the next generation of Starship launches, integrating advanced technologies and structural improvements. A crucial aspect of this construction is the extensive groundwork and soil improvement process being undertaken to ensure stability. The adjacent area of the former Test Stand B has been subjected to soil charging processes, which involves reinforcing the ground with materials that enhance its load-bearing capacity. This is particularly important given the soft and porous nature of coastal land, which can pose risks or subsidence under the immense thrust of Raptor engines. Additionally, SpaceX is exploring the acquisition of extra 16 acres of wetland from the United States Army Corps of Engineers. This expansion is aimed at providing additional space for the launch infrastructure and providing crucial logistical operations. The construction process for the new launch tower involves several critical stages, starting with concrete pouring to establish a solid foundation, followed by the installation of a complex pipe system. Once these preliminary steps are completed, the focus will shift to the assembly of the orbital launch mount and the tower itself. The OLM will be equipped with advanced clamp systems and booster quick disconnect mechanisms, ensuring secure and efficient launch operations. There is a considerable anticipation and speculation regarding the design of the new OLM. Observations from recent developments in Florida, where OLM legs were removed to reveal a new four-legged design, have fueled discussion about the potential design features at the OLM at Starbase. The current OLM at Starbase has six-leg design, but recent trends suggest a possible shift to a more streamlined four-legged structure. This change could offer several advantages, including reduced weight and potentially improved stability and ease of construction. And while the exact design details remain undisclosed, these speculations highlight the innovative approach SpaceX is taking to refine its launch infrastructure. The construction of the new OLM in the launch tower is being closely monitored, with expectations that these structures will incorporate the latest advancements in aerospace engineering. As SpaceX continues to push the boundaries of space exploration, the development at Starbase will play a pivotal role in supporting the ambitious launch schedules and missions ahead. The construction of the new launch tower at Starbase have been marked by the meticulous transportation and assembly of its segments. Since early this year, segments of the launch tower have been transported to Florida from the Starbase, showcasing logistical prowesses of SpaceX. On May 13th, 15th, and 17th, road closures in the area were announced to facilitate the safe and efficient movement of these large structural components from Brownsville Dock 16 to the Sanchez lot near Remedios Road. The careful planning ensures that each segment is delivered and assembled with precision, maintaining the high standards required for launch infrastructure. The new launch tower is expected to feature significant advancements in design and functionality, while the current tower stands at 145 meters tall and comprises 9 segments. There is speculation that the new tower could be taller to accommodate the next generation of Starship. This includes potential adjustments for Starship version 2 and the future Starship version 3, which is anticipated to stand at 150 meters. This enhancement are designed to support the increasing capabilities of the Starship program, ensuring that the infrastructure can handle the demands of the larger and more powerful spacecraft. As construction progresses, the design and height of the tower will become clear, and SpaceX enthusiasts are encouraged to share their predictions and insights in the comments. As SpaceX continues to innovate, the transition of ship testing activities to the Massey test site marks a strategic evolution in its testing protocols. Acquired in late 2022 and early 2023, the Massey test site has undergone significant transformation to become a state-of-the-art facility dedicated to advanced testing. This site has been instrumental in conducting cryogenic tests for both the Starship and Super Heavy booster, ensuring that all components can withstand the extreme conditions of space travel.